Welcome to the virtual tour of Bowen Laboratory. My name is Morgan and I am a graduate student here in the Structures Department at Purdue, and I am going to walk you through some of the exciting things we have going on at Bowen Laboratory right now. Let's walk on in through the front door. Welcome to the lobby. This is the first thing that you would see if you were here in person at Bowen. I would be here to welcome you in and suggest that you take off your coat and share just some general basic information about the lab. The lab is named after Robert and Terry Bowen, who gave the naming gift for the building, and we have been around since 2005, so we're just about turning 15 years now. I'm going to start by reviewing what our office space and general collaboration space looks like, and that's so that if you're a graduate student who's looking at Purdue and looking at the structural or large-scale civil engineering testing that we do, that you have a better idea of what your life and office space could look like. So the first thing I'm going to start with is our upstairs office area. So if I walk up the stairs here, we can see that we open to view and an easy access to the lab floor, as well as a variety of different seating and collaboration spaces. So this entire upstairs floor is really intended to be a space where it's really easy to collaborate and where we have a lot of open space for people to easily connect. So everything is movable, all the chairs are on wheels. We have a variety of open conference rooms, closed conference rooms, TVs that students can plug their laptops into and have formal or informal meetings. A lot of the walls and boards around here are also whiteboards so that we can use them and write on them really easily. Walking back into the room back here, this is where a lot of graduate students have their desks, and we have monitors where we just come in, we plug our computer in, and then we have a second monitor to look at some additional information. We have two small conference rooms up at the front here, so if you have a phone call you need to take, no problem, you can take that without disturbing the rest of the room. Right now, it's unfortunately and sadly really empty. We're not able to do office work due to COVID and our COVID protocols, but we're hoping and waiting for when we can get back in the office and enjoying this collaboration space. In addition to desks, students also have lockers. So if you have personal items that you want to make sure are locked up when you leave, you can throw those in the locker. That being said, I've worked out of this building for 3 years. I have left everything and anything on my desk, and I think it's just really a testament to the community that we've built that there's nothing that ever goes missing. It's a very safe place and a thing that I really appreciate. Under normal circumstances, our coffee maker and tea maker would be here, but unfortunately those have been put away right now. We're coming up on a conference room to the left here. This is a small size conference room. There's two closed small conference rooms like this, as well as one large conference room. So you can plug in, practice your presentations, or have a group meeting right there. I've headed back downstairs now to go look at our second office space. So to do this, I passed by the receptionist desk and also by a conference room that, again, we use these for small group meetings, to practice presentations, or for other more formal collaborations. This conference room can be reserved and has a system of either first come, first serve, or reservation based, depending on what we're doing in it that day. But continuing down this hall, we get to the second office space, and this office space houses both additional graduate students and our professors' offices. So at any one time, there's usually about a dozen active projects on the lab floor, but there can be upwards of 36 students that are working out of the lab, and that's because we have multiple students on projects, but also because projects are in a lot of different phases. So initially we have these planning phases, we then maybe move to some active lab work, and finish up with a lot of post-processing and writing. So this space is intended for students to be able to do all that with easy access to the lab, easy access to professors and their offices, and also access to office space to really get some of those additional office tasks done. Moving out of the office space into the actual lab space, this is the high bay area. This is where we do the majority of our large-scale structural tests. For a sense of scale, the lab is about 66,000 square feet, of which 60,000 are encompassed by the strong floor here and a couple associated rooms off the main area here. The clear height of the room is 54 feet, and big features, of course, are our big strong wall, which is 48 feet by 60 feet in this L configuration and 40 feet high. Fun fact, if you load the wall at the top with a million pounds, it will deflect a maximum of 0.1 inches. And that's really important when we're talking about the behavior, because when we use this wall, we're using it as a reaction frame. So that means I'm pushing on my specimen because I want to understand its behavior. And by knowing that my big wall essentially doesn't move, I then can know that anything that's happening is happening in my test setup as opposed to happening in my reaction and wall. There's a whole bunch of different projects that are out here right now. I know these kind of shots are a little sweeping and show a bunch of different things on the lab floor. We're going to walk down in a second and I'll highlight a couple projects that I think are of particular interest for what we're doing right now. I definitely want you to keep in mind that this is a snapshot of what the lab looked like when we took these videos yesterday, but is by no means necessarily what the lab will look like today, and definitely not what it will be currently doing in 6 months. The lab changes all the time, and we have new projects starting and old projects finishing very frequently. So it's really this versatile space, with the exception of this strong wall. We can take down and put up the remainder of everything that is out here. Okay, so this is a nice sweeping shot that starts at the end of our lab here, when you can see those doors. That's where we bring in things that come in on trucks, whether that's concrete or other materials. This is largely a staging area, so this is where we cast a lot of concrete or prepare specimens. And then when we're ready, we move them to essentially the left here in this shot of they move down the lab floor to various test setups. So you can see all that gray steel, those are reaction frames, as well as the strong wall in the back. We've now come down to the ground floor to look closer at specific projects as well as areas in our lab. This here again is the staging area. That's where we set up our formwork, we create our rebar cages, we pour concrete, or if we're doing some steel specimens, this is the side of the lab that they often come into first. Maybe we apply some sensors on this side of the lab before they go to the other side. And you can see we have a couple specimens here that we are getting ready to test. This is one of our first setups that we're looking at here. This is a shake table, so that means that it moves back and forth and we can input different earthquake parameters. There's a setup on here that's a variety of essentially springs and masses. We then have this big concrete block here, which is a counterweight, so it changes how fast the structure on the strong table moves. And then we have these two concrete moment frames here. And essentially you can see the difference between these two is one has that empty middle area and the other has that brick. And this project is looking at the effect of adding that brick infill on the drift capacity of different systems. Moving on further into the lab to another project. So this is a project that is looking at the post-fire behavior of bridge girders. So this is an I-beam from a real bridge here in Indiana. The bridge was being decommissioned and our lab applied for a couple grants to test different things with these girders. So this series of tests looked at what's the fire performance. So say I have a fire under a bridge, what does my beam look like and what is the capacity afterwards? So we actually took these bridge girders outside. We had a real fire beneath them, and you can see there's both that black charring as well as that white area, and then brought them back in the lab after their fire experience to understand their stiffness and their strength afterwards. So this is the failed specimen here that you can see that we've loaded, and you get all that concrete failure. And then we can compare that to girders we tested without the fire applied and understand what was the effect of this fire loading. This is another I-beam. It's actually from the same bridge, but it's a different project. So they're looking at different variables here. What they're looking at is they're looking at end regions. So as we come around the corner here, we'll see that this end region really has something applied to it. And this is FRP, so it's FRP sheets. It's essentially a special type of plastic that we've applied using epoxy or a strong glue. And we want to see what are some best ways to repair this region. It's really hard to get in and repair this region, but the rest of the girder is just fine. So it'd be nice if we didn't have to replace the whole bridge just because we have some damage in this area. So this project has looked at both existing techniques and innovative techniques like these FRP repairs to make recommendations to the Indiana Department of Transportation on what we could do in the future to best repair these end regions and have an understanding of, after they're repaired, what is their capacity. So how does it compare to a region that we haven't fixed, and what are the most effective methods? So moving on through the lab to some additional test setups, we're going to look at this test setup on the left here, which is those two side-by-side frames with those big actuators. And these were last used for a series of fatigue testing, so on deep bridge girders. So we have a deep bridge girder and we want to know what the fatigue or the cyclic behavior is of it, because that's commonly what we see on bridges as they get loaded at low load levels over and over and over, and understanding better how they behave and how fatigue cracks can propagate are things that we've used these test setups for before. This is a project that is looking at the shear strength of high strength rebar. So the two parts of this S specimen are cast separately, and then it's tested to look at the behavior on the plane between the two of them. So that vertical line in the center is where it failed. And we want to understand, based on how we make this cold joint, or how we make this joint in concrete that we had to make later in the field, how is the best way to make that joint, and how does our high strength rebar behave? So high strength rebar is pretty new. We can make stronger rebar, but we need to know how it behaves in order to implement it in the field. And you can see there's all these dots on these specimens. We do a lot of image capturing to understand better the stress and the strain in these specimens. So that means we track those little dots with a high-speed camera and can understand where the force and deformation or change in length is the highest to better understand the behavior. Guess what? We found a couple people! That's so exciting! We're moving in here to look at another project, the students' project, that is on the behavior of these walls. These are a special new type of walls that are often called speed core walls, and they have steel plates on the outside and concrete infill. So it's kind of like an Oreo sandwich with steel plates on the outside and concrete on the inside. And it's a shear wall. So what that means is it's the walls that you generally put around elevators and tall buildings, and they keep it upright with seismic and wind loads. So this is looking at wind loads. Here you can see that yellow actuator on the top. He applies a vertical force, and then you can see those 3 actuators on the side. He'll apply a force from the side, and he wants to understand the behavior of these. He's currently comparing what happens based on what he makes for the flange plates or what he makes on the behavior of the 2 plates on the end of the wall. And what happens if they're rectangles, what happens if they're C shapes, or what happens if they're W shapes. Moving into another space in our lab, this is the machine shop. So in this area, we can do a whole bunch of different fabrication things. One of our goals at Bowen Laboratory is to fabricate things like we would make them in the field. So that means if someone would make them themselves, then we want to make things ourselves. We want to cut them, we want to weld them, we want to lathe them, etc. But if it's something that they would contract out to a fabricator to do, we also are comfortable doing that, and we'll have a fabricator make specimens, all depending on what would be common to do. But we have the capability to do a lot of welding and other things that we'd need for our specimens. Moving out of the machine shop, back into the main lab here. This is behind the strong wall, just a little bit of a perspective of how tall this 40-foot wall is. For a test case, we've tested 3-story buildings in here before, and that's why the wall is so tall, so that we can do both 3-story buildings, 3 or 4-story walls, all of those we want to be able to. And we tighten things down to the wall, as you can see on the back. This is just a small little peek at some of our geotechnical area. We have the ability to also do a lot of geotech tests. This is our actuator bay. So this is where we store actuators and hydraulic hoses and rebar that we're not currently using that we will be using again later. So there's a variety of load cells, a variety of actuators that are all sitting back here, just showing that we have a whole capacity to do a whole lot of different things. Here's a quick look at the backyard. So in addition to our 60,000 square foot inside, we have another 80,000 square feet outside. And sometimes there's repairs or the such that we'll do outside, as well as we have a bunch of storage and a variety of different equipment that we can keep outside as well. And you can look, it's just starting to have some fall colors outside. This is the Intelligent Infrastructures Lab, kind of a lab within the lab. To the left here are 2 different test machines that can test in axial, compression, or tension to understand the behavior of components, for example, steel or rebar samples. And to the right here, we have a mini Bowen essentially in the back, with a smaller crane and a similar strong wall, strong floor setup, as well as a variety of different computers and a mini shake table, as well as a couple other actuators back here. This lab often works on real-time hybrid simulation, and that's a concept where it says I understand the majority of a system's behavior really well. There's just one component that I don't understand. So instead of modeling and physically testing the whole building or the whole system, I'm going to just physically test the component I don't understand, and the remainder of the structure I will use a numerical model that in real time will talk to my physical test. So I'll have my test of my component with actuators set up so that I can model the reaction from components and the structure around it, and then I'll have a model that talks to my physical test. Here there's a mini 6 degree of freedom shake table at the center with that small little structure set up on top of it. Moving to the next part of the lab here, this is where we cut a lot of wood for our concrete formwork as well as do material testing. The lab is capable of making its own concrete, but that's not really common. We much more often order concrete. That's what they would do in the field, so that's what we tend to do here. But occasionally there's projects that are making their own concrete. So for batching our own concrete, we have a couple concrete mixers that we can use. Continuing on, we get to our 4D machine, which will test a variety of cylinders and other concrete specimens so we can understand the material behavior of our concrete. It's really important for us to know if our specimen is stronger because our concrete's stronger or because our configuration was better. Heading back onto the main floor, we can see a good view of the whole lab from this end, and this again is from our staging area end. And I want to look at another test setup here. Here we're currently in the process of constructing and implementing some connection specimens. So it's actually this middle section that we're most interested in understanding. The wall at the bottom is very similar to what we saw earlier with those wind tests. And then it's this connection between this beam and this wall that we really want to understand. And this is a new and novel system, so it's recently been used, but there's limited testing for the effects of doing this connection differently. So they're looking at some different ways to connect these two elements, and then they're going to push and pull this top coupling beam and try to understand then better which connection types works best and what they would recommend people in the field actually build, designers choose to implement for future uses. The last thing we're going to do today is walk through the basement a little bit, and the basement gives us this perspective of, one, we can see bars coming down from the strong floor, so everything, all our test setups above are tightened down to the floor, as well as we actually do some projects in the basement. And we like to say that we're the safest place to be in probably the whole state of Indiana in the case of any inclement weather, just because of the amount of concrete that we have. Down here we've done a variety of different types of testing. We've done some impact testing. This gray thing to the right here is actually essentially a rebar cannon. It will shoot smooth bar at specimens, and we have some different triaxial geotechnical setups. The different kind of projects that have happened down here, we've shot bars at walls to understand the impact performance. There was a project down here that looked at Kevlar vests and understanding what's the impact of a second or third projectile on the performance of bulletproof vests. We also have a bunch of books, procedures, there's conference proceedings that are all down here as well. And that's essentially because civil engineering relies a whole lot on current, new, novel techniques, but also on understanding the whole field in general. Thank you for coming on this lab tour today. I hope that you learned something about what Bowen Lab looks like, as well as some of the cool, novel projects that we're working on. And we hope to have you out to the lab and give you an in-person tour sometime soon. Thanks.